Much has happened since Americans first landed on the moon. Space has become a globally utilized resource. Our skies are filled with satellites. People are living aboard the International Space Station, and scientists worldwide study our solar system with robotic missions. A renewed vision for space exploration has prompted NASA to develop a sustained human presence on the moon, using its new human spaceflight architecture known as the Constellation Program. The Orion crew exploration vehicles and Ares launch vehicles, complete with Altair lunar lander, will replace the space shuttle, making it possible for return missions to the moon and future missions to Mars and beyond. Travel to Mars and other destinations require us to learn to survive in forbidding faraway places across the vastness of space. Living somewhere other than Earth will be incredibly different. The unusual, harsh lunar environment has its own unique challenges. In order to understand how we will live on the moon, we first have to test lunar surface systems and operational concepts on Earth. One very effective way to accomplish this is by using analogs. An analog is a representative environment that has similar features of the target mission's environment. Lunar analogs include locations underwater, in the Arctic, terrestrial impact craters, and volcanic lava flows. These extreme environments greatly enhance the ability to analyze architectural concepts and simulated lunar conditions and enable experiments with long-range and long-duration expeditions. NASA and the National Science Foundation teamed up to develop an inflatable shelter that was deployed in Antarctica during the months of January and February 2008. Testing in Antarctica was done to study the durability of an inflatable habitat in an extreme environment. From this field test, engineers were able to learn about issues dealing with the packing, transport, and deployment of a large inflatable habitat system. They also gathered valuable data on how to best use in situ materials for radiation shielding and how to improve current lunar dust mitigation practices. The Hot and Mars project is a field test mission that is held annually in Devon Island, Canada, just above the Arctic Circle. Devon Island's isolation, lack of infrastructure, vastness, and large-scale topography offers a unique opportunity for lunar exploration operations, design, development, testing, and training. Houghton is the only terrestrial impact crater set in a polar desert and is the best preserved complex crater on Earth. Its similarities to the variety of medium to large impact craters found on the Moon make it an ideal model for future lunar outposts. The NASA Extreme Environment Missions Operation Project is the only underwater research facility in the world. In partnership with the National Oceanic Atmospheric Administration, the Aquarius habitat was created and provides some of the best conditions for practicing space operations in a harsh environment while simulating working in 1/6 gravity. This unique setting has helped lunar surface operations and demonstrated exploration procedures with human and robotic collaborations. Testing in this extreme environment gives astronauts a broader knowledge and awareness of exploration risks, issues, and objectives. Numerous discoveries have been made on human health, engineering, telemedicine, and space operations that directly relate to spaceflight needs and are being implemented with each mission. The first phase of the Short Distance Mobility Exploration Engineering Evaluation Field Test took place in Moses Lake, Washington in June 2008. The Moses Lake Analog Test Site provided the opportunity for 1 to 2 kilometers range expeditions that are not available at NASA field centers. The variety of slopes and soil types provided environmental realism for the testing of robotic rovers and EVA suits. The scientists and engineers were able to gather accurate timelines and surveying data that would not be available if testing was performed at a field center. Black Point Lava Flow, Arizona was the selected site for the October 2008 field tests based on EVA surface operation objectives. The terrain and size of Black Point Lava Flow provided a geologically similar environment to the lunar surface for crew members to study. NASA tested the crew members' ability to make observations from the unpressurized rover, where the crew members sit outside, and from inside the small pressurized rover. The Black Point landscape also enabled the small pressurized rover to undertake science focused on 1-day and 3-day traverses with ranges that varied from 13 to 19 kilometers per day, with a total distance traveled of 142 kilometers. The In Situ Resource Utilization Demonstration Field Test took place in November 2008 at Mauna Kea, Hawaii. In the current lunar exploration architecture, In Situ Resource Utilization has been identified as providing 1 to 2 metric tons of oxygen per year for astronauts during lunar surface operations. The field test demonstrated how to lower the architecture risk by successful demonstration of end-to-end oxygen extraction, separation, and storage from the volcanic material. The in situ terrain, rock distribution, soil materials, and permafrost at Mauna Kea provide good simulation for the lunar polar region and tests hardware and operations beyond ability of laboratory and available rock yards. These early demonstrations of in situ resource utilization will provide lessons learned for subsequent hardware and mission concept development. In addition to the successful technical field test accomplished, this test, hosted by the University of Hawaii at Hilo's Pacific International Space Center for Exploration Systems, or PICES project, showed how successful collaboration between members from federal, state, and local governments, 4 countries, multiple companies, and several universities can occur, serving as a good model for our future lunar exploration missions. By 2020, astronauts will return to the Moon to live and work on the surface, all made possible with the aid of successful testing of analog systems and procedures in simulated environments here on Earth.